Everyone, Corey here with our first tutorial on building your own cloud server. Funnily enough, I actually recorded this entire tutorial series. You'll see all the videos that I made over here. And yet the entire, oh man, it was like 2.5 hours total of all the videos together, and they all got corrupted. But redoing it now. Oh yeah, good way to spend my weekend. But no, it's all right. So we're going to start now with the basics of sockets. All right. So since we're not going over the direct basics, I won't spend too long on sockets because there's a lot of great tutorials out there. Like Draps TV is where I learned sockets. Centex also has some good stuff on there. The new Boston has some stuff out there. Like everyone's got stuff on sockets. Okay. So we're just going to kind of dive right in. If you want to learn a little bit more detail about sockets, I'm going to go explain it as I go. But if you want to learn like really in depth and start off a little bit slower than I'm going to go to those guys. Okay. So the socket library is already basically in Python. It's already included in the standard library. If it's not, you've had a problem with your installation. So just a quick test of just doing the shell and just going import socket. Should be fine, right? So to make a socket object, I usually just call it sock. I think that's actually what Draps does because that's where I learned mainly of socket. Socket.socket. Okay, we're doing this in Python 3. Okay, in Python 2, if you guys are trying to follow along here, you'll need to put some stuff in here to say the type of socket, whatnot. But Python 3 just defaults to a couple things, and they're the exact things that we want. The things we want is a TCP protocol socket. All that means is it does a lot of fancy error handling behind the scenes. Draps does a lot of stuff explaining that. There's a bunch of fancy error handling which we want for a cloud server. Obviously, you don't want your files let me just throw it at the server, hope it gets it, even though there's thousands of other people. No. All right. So what we're going to do is we're going to start making the server right now with this socket. Okay. So we're going to have to do a special thing. Go socket. Sock.bind. And it takes two inputs, but they have to go, well, technically one input, right? Because it takes a tuple, however you want to say it, in the middle, right? And this tuple has two things inside of it. So it's kind of like it takes two parameters, but you got to put it inside one thing. Okay. And I'll say what this is in a sec. 5,000. Okay. So what did I just do? Well, I took our socket object, all right? A socket is like a port on a computer that we can connect to, or that we can use to make outgoing connections if we want, all right? It's like and the server version of it, all right, when we bind it, we're basically saying that it's basically like a port in a harbor, right? And it can take in boats coming in on it, and they can unload info, we can give them info, we can do a lot with the socket, all right? We can trade things. If you want to do an outgoing connection, then a socket's kind of like a ship that goes out to somebody else's port and comes back, okay? It's actually kind of funny because they're actually named ports on your computer. Oh man, top dollar analogy. The two things we input are an IP address and a port on your computer, right? So we're telling this guy right here, he's binding, so he's going to be our server, he's going to be our dock, okay? We're basically giving him the address that he's going to dock on, okay? And the address that he's docking on is, well, normally, if you know anything about IP addresses, this doesn't look like a normal IP address. And that's because this is a special IP address that always reroutes to your home computer. You'll see the bumper sticker, there's no place like 127.0.0.1. It's the home IP address. So I got to get me one of those. This is a port number. Your computer's like upwards, I don't know, like 65,000 ports, I think. It's got a huge number of ports. Everything below 1,000 is kind of used a lot for like, I know... oh man, I'm blanking on the numbers, but like I think it's like 82 or 108 or something is HTTP request, 22 is like SSH request, The lower guys are all used for kind of basic functions, but you have all these higher numbered ports that are free for you to do whatever. Online games you may play, like Warcraft or Dota or League, they all use these ports to go talk to people outside of your computer. And get information, so you can all play an online game together. You need to know what the other people are doing, so you have to go send out info through, the little ship going out. So this is the port we'll be working on, 5,000. So anybody coming into this port will accept. Okay, 5,000 not used. There's like, if you play Warcraft 3, I know somewhere. I usually use in the 5,000s because they're hardly used for anything, but I know Warcraft 3 is in the 5,000s, I think. So if you have Warcraft 3 server running, just make sure you don't interfere with it. I think Age of Empires is somewhere up here too. Man, that game was so good back in the day. It's still great. There's still a big competitive scene, by the way. it's like 2016. They're still, damn. All right, moving on. So when we bind it here, it's going to sit on there and wait for people, right? So first we got to give it one extra little setup. We got to say, listen. We got to say, hey, here's how many people. I was first confused what listen does, okay? But listen does an interesting thing. It doesn't actually start it listening, which, contrary to the name, you would think it does. But what it tells it is this is how many people you should have waiting in line, all right? If any other people come to the back of this line, so if I have 5 clients waiting to connect, and I'm dealing with the first guy, like, papers, please, and I'm dealing with him, finding out if he's someone I want on here or not, and a 6th guy comes in line, he's like, hey, what's going on over here? He'll be rejected automatically. It'll be like, hey, sorry, line's full, we can't get to you all, go home. You can put whatever number you want in here, like I can put 100, so the 101st guy in line is rejected. As soon as I let somebody through, and there's now only 99 guys in line, and the 100th guy comes again, that previous 101st guy comes, well, now he's the 100th guy, and that's okay. We'll let him sit in line. So you can specify this any number you want. It really depends on what kind of server you're working on. Like say you only want you or your friends connecting. You don't want a bunch of people spamming your server. You can put like 3, because you only expect like 3 of you to be on, at a time or something. I don't know. I usually just set it at 5. If I'm working on my server, sometimes it just says 100. I really don't need it that big because I have some friends that go on my servers. We share robotics files between them. We could use Google Drive, but we're too leet for that. All right, we're too leet. Leet speak. So sock.accept is what starts it listening. Okay, so this will say, hey, sit here listening until somebody comes in, and then accept them. And it returns 2 parameters: the connection and the address. The address is a list. A list. I've been learning Lisp programming language, I said. But a list has multiple things in it, but the first element's the IP address. Whenever you want to read the IP address, you're just going to go add or 0, right? I actually don't know what the other numbers on the end of it mean. I'm trying to figure that out, but they're weird. Like, they're really weird numbers. They're not even like port numbers. I don't know what they are. If somebody knows, let me know. I'd really appreciate that, by the way. Okay. The connection is the actual like code object that houses like the pathway. Think of it as like this connection stores the pipe that we send info down or talk through. It's like the actual physical ship. So if we want to send things, we give it to the ship. If we want to receive things, we take them from the ship. Okay. So I'll do that, and then I'll do while. I'll make something called message. Okay. And then I'll go while. Message does not equal right quit. Boom, ba-doom, ba-doom. Okay, so while message does not equal right quit. So the message, I'm making a variable right now because we need to be able to accept things from the ship when it comes in, right? They're going to be sending us stuff, okay? So I'm just making a little variable to hold whatever they send, okay? Actually, I'm going to do this real fast. But when they send stuff, it's not going to come in as strings, all right? Think of like the ship can only bring so much, Think of like the pipe between the computers is so small. We can only fit bytes. We can only fit raw bytes through there because that's the only thing the computers can really talk through on the internet, right? So we need to make an object that'll hold bytes for us, okay? And when we send them, we need to make sure we send the byte code, okay, not the string. I can't say just, hey, send over the message, hey, how you doing? I need to first convert that to bytes and send it over. So to make sure that this variable holds bytes, I'm just going to give it a byte value. So I'm just going to say bytes of an empty string. And if we come into the shell and we just go, if I go bytes, empty string, bytes. Actually, sorry, we can do this. Encode, sorry. Encode UTF-8. This is another way to do it. Boom. So it returns an empty string. This bytes means it's displaying me, like, it's assuming as normal human beings that we don't want to read bytes, right? This right here returns bytes, 1s and 0s. It assumes we don't want to read those. So when it prints it out, it's going to say a B and these quotations to say anything inside these quotations is actually bytes. But I'm giving you the translated version so you can read it. And so, for example, if I go hi.encode, first you got to spell the things right. That's the most important part. And I go, okay, so bytes, hi. So that's the message we encoded, but in reality, this is bytes, right? So So instead I can go, you can only use the keyword bytes if you have things, by the way. So in Python 3, you don't need to do UTF-8 encoding, I believe. I don't think you need to put this in here. But there are various types of encoding, like hexadecimal, and there's multiple other bases. So hexadecimal definitely is used a ton. I've used it a ton. So it's good practice, in my opinion. I mean, it's opinions vary. But when I do projects with people and we're encoding things, I always put that in there. So when they're reading it, they don't need to remember. Oh, say they're a Python 2 user, and they're like, well, what encoding is it? This won't work. Well, I just put UTF-8 in there for readability, just for people to read it. If you don't want to put it in there, that's totally fine. But it'll still work. It'll still work, I believe. It used to. So we'll do con.receive. Okay? All right, so we're going to take that ship that came into our harbor, that little pipe between our computers, and we're going to receive data from it. You need to put a parameter in here, though. How much we want to receive, right? If a ship comes in here with like 50 billion bags of tea, right, and into your harbor, and you're like, all right, I only want like 50 of those. I'm sorry, man. So we're going to specify how much of the message we want to take in, okay? But if somebody arrives with like, say we wanted that 50 bags of tea, and somebody comes in with 5, right? Well, we'll still take it all and just say, hey, we didn't get all 50 we wanted. So don't worry if you send a message under 1024 bytes. The computer will see that there's a terminating bit on the end of those messages, and they'll see that and go, oh, I wanted 1024 bytes, but I got a message less than that, and it will return however much it got, right? So when you're doing size-sensitive message, always make sure to check that you got the full size. And we'll see that later when we're sending files, because we got to send them in bytes, right? I can't just say, use the file and send it off. We got to send it in bytes, which will get interesting how we do that. Not that hard, though. Now, since this got received as bytes, and we want to, maybe we want to print whatever they're sending in, right? We're doing a chat client, maybe, and we're receiving whatever they're sending to us, okay? Well, first off, I got to print the message, of course. But if I print it, we'll have that weird B in the quotations, which could be hard if you're sending, like, say, commands to the server, and you want to parse some things, and you look at it as a string. It won't even let you parse it straight off. But if you try to, like, print it and look at it yourself, the bytes thing will get in the way, and it won't look very nice. So what we have to do is we have to decode it. Okay. Now, when I decode it, it'll do the opposite. Instead of turning into bytes, it'll take bytes and return it to the string. So if I print this, it will not give me that B. Now notice that decode does not actually edit what's inside message. So if I were to, print message again, I'd get the B again, right? Because it doesn't change what's in message. It's just returning those bytes if they were a string. But it doesn't change anything in there, which is important to remember, because we're going to be later dealing differently if something's a string or if something's a bytes, or if something's in bytes, okay? So for now, I'll actually just go, message con.receive 1024.decode UTF-8. And this works because con.receive 1024 returns bytes, and then I'm going to decode it in UTF-8 form, and that'll give me a string. So there's two different ways you can do that. You can just leave messages bytes and decode it whenever you need it. I know that later on in the server, because I've recorded the whole series already, that we are going to be looking at message and seeing if there's any user-specified commands in there for special things. And so I know, instead of writing decode like every time I want to check for a different message, I'm going to just decode it right off the bat, and actually change what's in there to a string. So I don't have to decode it every time I want to look at it. You don't have to. You can make a separate variable that stores the decoded one and keep them. It's really up to you. If I want to encode it again, it's just one simple encode statement. It's up to you. It doesn't matter. And then let's add in a couple things for us to help look at this. So print server started, listening for clients. This is just for us to know that our stuff is working. Print closing server. Now, this connection is going to remain open until we close it. Usually if you shut down the program, your server shuts down, and the connection on the other side will see, whoa, hey, this guy shut down on me. I'm gonna stop. Especially if he's sending things, he's gonna see, well, it terminated the connection. I can't send anywhere, and it'll shut down. On our other program, it'll hit an error. But if the other side's receiving, like say the guy on the, say the other guy's waiting for the server to send a file back to him because he wants to download a file, and the server shuts down. That connection will remain open. The other guy will be sitting there looping. We don't want that. So if somebody tells us write quit, or like we hit an error and we bust it out of this while statement, we don't have any try excepts that'll bust us out. Yeah, but in the future, we gotta close that connection. Con.close. Okay. It's basically a cleanup thing. Like 9 times out of 10, even more than that, I say 99 out of 100 times. If you close the program, this connection will be shut down automatically. But it's just good practice for kind of janitorial work, making sure everything's nice, neat, and tidy, right? Con.close, and then we'll do sock.close. We'll shut down our server as well. I'm just going to put end connection. Just putting these so I know where the program's at. It's useful for debugging. Nothing else I need to do. And now let's write the client. Okay, so I'm going to Does anyone like my custom desktop that I made, by the way? Made it Rainmeter. Great app for, program. I shouldn't say app. For making your own desktop scene. Usually I have nothing on here, so it looks cooler, but I have all the recorded files from the past tutorial. All right, so now to make the client. All right, see, look how I do this before I code. That's like a ritual, All right. Maybe we can spell, socket right. Okay, I'm going to do sock. You got socket, just setting up the socket again. And then we're going to do something slightly different. You already see that I'm typing something different. Let me just finish this out and I'll explain. Hang on a second. Boom. All right, sock.connect. Whoa, what's going on? Well, here we were the port master, right? We were the harbor for people to connect to. So we bind to this location. We're sitting here. We're planted there. Like, this is our territory. We are here. Now, connect is when we're sending that ship out. We're like, oh, hey, go connect to somebody. All right? He's like, okay, and it sails out to go to whatever location. We told it to go out and then immediately reroute back to ourselves. Great job. Yeah, great expedition. Your first sailing exercise. And we told it to connect to port 5000 because we have this guy waiting on port 5000. Not a very expeditious excursion on our part, but we're baby steps. Adding in some more stuff for us to read. And notice again, it takes in a tuple, by the way. Okay. Sock.connect doesn't connect anything. Okay. Connection to server. Okay, that's supposed to be connecting. Shouldn't get too worried about that though. Print connected to server. Okay. And then we'll go print just to give our user. Actually, no. We'll do the same thing before. We'll make a message variable. Okay, so now that we've connected. Okay. So we've connected through sock.connect. We've connected. We see that. And now I'm going to make a message variable that's going to store our message to give to them. Okay. So notice over here, we had to talk through the connection that they set up with us, right? We have to talk with the ship they sent to us. But here, you're going to know something different. We can talk down the straight up sock object, okay? Because this is a client, well, this is a server, okay? So this guy, he set off by himself, and he's there. So he's going to talk, through his ship. He's going to talk through himself, all right? Through his pipe that he sent out there. Well, here we have to wait for a pipe to be given to us, and then talk through that pipe, okay? So I don't have to store any connection and adder from this guy, right? I can directly talk down my sock object, right? I'm just going to make it store some bytes. Okay. And then I'm going to say while message does not equal write quit. The reason I use right quit, just like WQ, is because it's a standard command for a lot of like Linux applications, and it's just a habit of mine to use it for whenever I need a command that ends something. It's something I just like to use personally, just an arbitrary. You can use whatever. You could have it be some long thing, or just cancel, or whatever, or just the word close, whatever you want. So what doesn't equal right quit? Well, I'll say message is equal to input. And I'll do it like command line style. Boom. All right. I'm sure you've seen that. In fact, I think that's the thing for the Python shell as well. Let me look. Yeah. All right. Cool. Put a little space there. So when they input things, it's going to return a string, right? That's an issue because, like we said, we send bytes, and we already have message storing bytes, right? So I'm going to encode. You know what? Change my mind for this one. Just for this message, because I know later, the same reason over here that I want message to be a string, because I'm going to be parsing it to check if commands are being sent. I got to do the same thing on the client side. You'll see that we do a lot of the same things on the client server side. Why? Because if they get out of sync the sockets, like what both guys are trying to send, the info will just crash into each other. It will not go well at all. They'll miss it. In fact, if they both try to send, they'll think the other is blocked, not listening, usually, and shut down. If they're both receiving, they got caught in this loop where they're like, all right, where's the info? Waiting for it. Let's go. And it never comes. Never comes. And you get an infinite loop. It's really bad. Really bad. It's, both of those are death sentences. So we usually like to keep them almost identical in how they work. So we know they're in sync. So I'm just going to have this hold a string then. Okay. I got to do that over here too. I got to make it not hold bytes. Because you see right here, we're decoding it. It's holding a string. I bet you guys caught that. I bet I didn't. I bet people are screaming at me. All right. So, yeah. Input. I'm just going to do that. Just to make sure, because every once in a while in Python, if you put in like a 5, it'll come out as an int. So just every once in a while. I know it used to do that. It probably doesn't anymore, but just in case, I like to put a string there. And then I will go sock.send message, and we're sending bytes. So now I got to decode it because I chose to keep it as a string. Okay, consequences of your actions. Okay, just sending it down sock. See, I don't have to make a different pipe. I don't have to wait for one like these guys do. Here I can directly connect or send things down the socket, right? Because the socket's going out there and connecting and saying, here are things. I'm going to receive your things, and so on and so forth. Well, here, the server's sitting there and has to wait for somebody to connect to it, and then we take that connection, and then we can talk down it, okay? All right, I just want to handle it, because that was really confusing me when I first started. And then I'll print connection closed. So if we enter right quit, it'll just go down to here. If we send right quit, it'll go down to here. So let's test this guy, okay? So I'm going to save them. I would save them as a basic client and whatnot. But as you see, I already recorded everything once again, and all the videos got completed. So I'm just cloud tutorial. Actually, no, I'm just going to keep my desktop. You'll see why in a second. I'm going to keep it on my desktop. All right, I'm just going to call it B server. Okay. And this guy, I'm just going to save as B client. Now, if I were to test this, right, and I run the server, server started listening for clients. Great, okay, no errors. That is, what a wonderful start. If I run this, though, as you can see, oh, no, yep. See, it stops the previous guy and starts your new program. You can only have one thing running in the Python shell at a time, and then it goes, oh, hey, there's no connection, it's actively refused it, there's nobody waiting for us. Okay, well, how do I get around this? Okay, well, not bad. I can run this module. Okay. Then what I'm going to do is, and this will be a common theme throughout the tutorial. Oh, God, that's Anaconda. Oh, God, don't run that. Command prompt, yeah. So what I can do, though, is I can get around that running multiple, and some of you may have already run into this. Welcome to your command line if you don't use it. Python b client.py. It says it doesn't exist. I saved it on the desktop, didn't I? bclient.py. Didn't I save it on the desktop? You can run it from the command line. Basically, let me look. Where did I save it? Oh my god, I did not save it on the desktop. Right. Save as desktop. Cool. Alright, make sure you save things to the right folders. Alright, cd desktop. Python bclient.py. Connecting the server, connected to server, and boom, it's opening up. We should add in something real fast to the server. Print. Okay. Connection made at IP, and then we'll go str. Adder 0. Remember, the first element of that list of all the address information is the IP, and that's really all we care about. We know what port it's on because we set up the port. So all we really want to know, just making sure all my parentheses match up, looks good. I'm actually going to restart these just so we see that. Perfect. Okay. Command prompt. CD, gotta go to my desktop. I'm doing CD desktop if you don't know that. It just means change directory. I know my paths, so. Man, that's how you know you're elite, when you know your paths. Connect to the server, and then what we should see over here. Connection made at IP 127.0.0.1. That connection, when it inbounds, carries that info for us. Oh. There we go. Alright. So, if I send hi, string decode, decode. Whoops, encode. We're encoding it. Probably all saw that. MD server. And as you saw, they both kind of got a little messed up. Well, the server actually didn't. The server was waiting for info to be sent right there. And it was just sitting there waiting. It got kind of loop. Well, the other guy failed, right? And so that's when they get out of sync. You need to make sure they handle errors correctly. And when they handle an error, they need to tell the other guy, hey, I'm aborting, I'm changing my game up, and stuff so that they don't fall out of sync. If I go hi, we get hi over here. Hello. Hallo, wie geht's? Na gut. Wie geht's? Na gut. In German. But see, it's sending. And then if I send right quit, closing server and connection closed. So we have, boom, right off the bat, we have, see, I didn't use my webcam in the last recordings, and now I realize you can see my hand gestures. Just hands, to celebrate. So we have a basic client and server set up, and now we can expand upon this. This is a really good start to what we want to do with our server. From here, next video, I believe, we will address the problem of only one client can connect. If we try to connect with another client, it'll say, whoa, this guy refused my connection, right? Because the server is busy talking to this other guy. That's not good. We don't want that at all. We don't want the server to handle our clients at all. We don't even want to have them look at them, all right? We don't want to be like, oh, hey, who are you? Okay, cool, and pass them on to another guy that'll deal with them. And to do that, we're going to need to implement threading. And there comes some problems with threading, but we'll adjust that. And so next video, we'll make a multi-threaded server, okay? And have it so we can have as many classes as we want connecting. All right, so I will see you next time.